Welcome to GATE coaching session. I am Ms.KUMARI assistant professor working in SA Engineering College, the Department of Artificial Intelligence and Data Science. And today we are going to discuss about subject machine learning and topic decision trees. This is the outline. Today we are going to discuss about these topics: machine learning introduction and decision trees, an example, pros and cons, problems and solutions, applications, and some sample MCQ questions. First, let me recap what is machine learning. Machine learning is a branch of AI which focuses on developing models and algorithms. It is a training model to learn from past experience and predict the output values for the new data, and also it improves its performance over time. It helps to predict for massive amounts of data. It helps deliver fast and predicts accurate results. Next, types of machine learning. We know we are two types: supervised machine learning and unsupervised machine learning. Supervised machine learning, it's a model gets trained on a labeled data set. That is, we know both input and output parameters. It's again is two types. First, regression algorithm and classification algorithm. Regression algorithm, it predicts continuous values, example temperature prediction and weather prediction, etc. And classification algorithm used to predict categorical values. And next, unsupervised machine learning. This algorithm used to find hidden patterns and relationships using unlabeled data sets. Next, we move on to our topic, decision trees. What is decision tree means? It's a hierarchical tree-based algorithm used to classify or predict outcomes based on a set of rules. It works by splitting the data into subsets based on the values of input features. The algorithm recursively splits the data until it reaches a point where the data in each subset belongs to the same class for the target variable. The resulting tree is a set of decision rules that can use to make predictions or to classify new data. Next, type of decision tree algorithm. A decision tree is a supervised learning algorithm, and it is classified into two types: classification algorithm and regression algorithm. First, we see a classification tree. A classification tree is used to classify data into different classes or categories. It works by splitting the data into subsets based on the values of the input features and assigns each subset to a different class. Next, regression tree algorithm. This algorithm used to predict numerical values or continuous values. It works by splitting the data into subsets based on the values of the input features and assigning each subset a numerical value. Next, let me discuss terminologies used in decision tree algorithm. First, root node. So what is root node means? Is a node present at the beginning of the decision tree, and decision node means the node we get after splitting the nodes. That is the decision tree. Next, leaf nodes. The nodes where further splitting is not possible are called leaf nodes or terminal node. That is, afterwards we couldn't able to split that one. So branch tree or subtree, a small portion of a graph is called subtree, subgraph. A similarly subsection of this decision tree is called subtree. Next, pruning. What is pruning means? Is nothing but cutting down some nodes to stop overfitting. And then here I have given a decision tree diagram. So decision tree, that is a root node where it starts, and then decision node. Here is a leaf node. Next, decision tree is a flowchart like model used for classification and regression. It splits data based on features to make predictions. And a decision tree is a hierarchical tree structure which consists of a root node, branches, internal node, and leaf nodes. It works like a flowchart. Help to make decisions step by step, where internal nodes represent attribute tests, branches represent attribute values, leaf node represent final decisions or predictions. This is a decision tree are widely used due to the interoperability, flexibility, and low pre-processing needs. That's why we are using decision tree algorithm. Next, how it works. The decision tree algorithm works by selecting the best feature to split the data at each node. The best feature is the one, it provides the most information gain and also the most reduction entropy. That is, information gain must be more and the entropy will be less. First method, information gain, is a measure of the amount of information gained by splitting the data at a particular feature. Information gain tells us how important a given attribute of the feature vector is. Next method, entropy. This is a measure for the randomness or disorder in the in it. That is, it measures the impurity of a given attribute. For example, ID3 algorithm, it uses entropy to calculate the homogeneity of the sample. The sample is completely homogeneous, the entropy is 0, and if the sample is equally divided, it has entropy of 1. And another measure, Gini index. It is another metric to measure the impurity of an attribute. It is used in CORT, that is a classification regression tree algorithm. The decision tree algorithm uses these metrics or measures to determine the best future to split the data at each node. So next, let me discuss an example. Let us imagine we are trying to predict if someone will buy ice cream or not. So what is the first step? We have to collect data. This first need label data. So for example, we have to collect the temperature of the day, and then weather of the day, whether it's cloudy or sunny, and time of the day, whether it's a morning, evening or afternoon or midnight. So whether they bought ice cream or not, that is the previous data. So we have to collect all this information, and step 2, choose the best future to split. So we can apply the decision tree concepts like entropy or information gain or Gini index. So in entropy measures, it measures disorder in the data, that is the impurity of the data. Next, information gain tells us how much a future improved decision making. Next, Gini index, another way to measure the impurity of data splits. Next, step 3, repeat the process. The tree keeps splitting data until all data is classified, until it hits a stopping condition, that is like maximum depth is reached. Next, step 4, prediction time. Now, so based upon our previous data, so we are predicting the final output value. So now if someone asks, will a person buy ice cream at 5 p.m. on a hot day? Yes, obviously what will be our answer? We'll buy answer, because it's a hot day. So the decision tree will follow a path is yes and no answers until it lands to a prediction. So finally we conclude its prediction will be yes, will buy. Next, let us discuss about advantages and disadvantages of decision tree. Some advantages: easy to understand and interprets, and no need to normalize or scale data, and works with both numerical and categorical data, and is a fast and efficient method for small to medium sized data sets. Next, some disadvantages: that is overfitting, unstable, not always the most accurate. So first, what is overfitting means? Decision trees can memorize data too well, that is, it acts overreact to the noisy data also. Next, unstable, that is, small changes in data can create a whole different tree. Next, not always the most accurate, especially with the noise data. So it acts to the noise data, so it will predict some inaccurate data also. Let me discuss about some problems in decision tree. So first problem, overfitting. Overfitting is a common problem in the decision tree method. Overfitting occurs when a model fits too closely to the training data and may become less accurate when encountering new data or predicting future outcomes. So in this condition, a model memorizes the noise of the training data and fails to capture the essential patterns. So this leads to a poor performance of unseen data. Next, here I have given diagram that is underfitted. Underfitted means it not consider the actual data itself, and good fit means is a good fit method, so it consider the actually fitted data. Next, overfitted means it react to the noisy data also, so it consider all the data present and leads to an inaccurate data prediction. Next, instability. It can be unstable, which means that small changes in data also may lead to a significant difference in the tree structure and predictions. So bias towards future with many categories, it can become biased toward futures with many distinct values, which focuses too much on them and potentially missing other important futures, which can reduce prediction accuracy. Therefore, the accuracy will be low. Then we will discuss about some solution to our problem. So decision tree predicts well for the training data, but can be inaccurate for new data. If a decision tree model is allowed to train to its full potential, it can overfit the training data. Just to avoid overfitting, we can use pruning technique. So let me see what is pruning. Pruning is a technique that removes parts of the decision tree and prevents it from growing to its full depth. Pruning removes those parts of the decision tree that do not have the power to classify instances. That is, we are removing the unnecessary nodes. That is our unwanted nodes. So it is a decision tree pruning diagram, and then here we are removing the unwanted nodes. So the reverse process of splitting is called pruning. Instead of growing the tree by adding more decision rules, pruning involves removing unnecessary or less important rules from the tree. This helps reduce the tree complexity, making the model more efficient and less prone to overfitting. So pruning can be two types, pre-pruning and post-pruning. Pre-pruning means the techniques that stop growing the tree before it reaches the point where it properly classifies the training data, that is early stopping. Next, post-pruning the tree involves pruning the decision tree after it has been fully grown and trained on the data. So what is the key difference between these two means? Pre-pruning prevents the tree from growing too large in the first stage itself, and post-pruning simplifies the full-grown tree, that is after growing incompletely. Next, what is pruning? To avoid overfitting, trees can be pruned to remove branches that have little power. And next, other methods to solve this problem: random forest, collection of decision trees with averaging to reduce variance. And another method, gradient boosted trees. This, for example, XT boost, light GM, and this is sequence trees to reduce bias. Let me see summary key concepts of decision trees. Splitting criteria and stopping criteria. So what is splitting criteria means? Common ways to decide where to split. That is, we can use information gain and entropy and Gini index or Gini impurity method and various reduction. These are the measures. This is information gain used in ID3 and entropy measure of disordered randomness and Gini index used in CART, that is classification regression tree algorithm, and various reduction for regression. Next, stopping criteria: maximum depth of the tree, minimum number of samples in a node, and no improvement in impurity. Let me discuss about some applications of decision trees. First, in loan approval, that is in banking. So banks use decision tree to assess whether the loan application should be approved. The decision tree is based on factors like credit score, income, employment status, and loan history. This helps predict approval or rejection, helps in enabling quick and reliable decisions. Next, medical diagnosis. So in healthcare industry also, we can apply this decision tree algorithm. So why means to classify the patients whether they are belongs to diabetic or non-diabetic categories. Next, in predicting exam results in education, institutions used to predict where a student will pass or fail based on factors like attendance, study time, and pass grades. This helps teachers identify at-risk students and offer targeted support. And next, in fraud detection. So in finance, decision trees are used to detect fraudulent activities such as credit card fraud. By analyzing fast transaction data and patterns, decision trees can identify suspicious activities and flag them for further investigation. And then let me discuss some sample MCQ questions. So first question, what is a decision tree in machine learning? So what are the choices given? A method for clustering data points, and B, a supervised learning algorithm used for classification regression, and C, and supervised learning technique for dimensional detection. What will be the answer for this? So what is decision tree in machine learning? A supervised learning algorithm used for classification and regression. Answer is B for that. Next, second question, in decision tree, what are the internal nodes responsible for? So what are the choices given here? A, representing the root node of the tree, and B, making prediction based on input features, and C, connecting nodes to form branches, and D, testing specific conditions on input features. So what is the answer for this? The answer is D. That is what internal nodes responsible for testing specific conditions on input features. Next, third question, what is pruning in the context of decision tree? So answer A, adding more branches to increase model complexity, and B, removing branches to prevent overfitting, and C, standardizing the splits across different nodes, and D, converting continuous variables into categorical variables. So what will be our answer? Pruning means removing branches to prevent overfitting, that is answer B. Next, fourth question, what is entropy used for decision tree algorithms? So what are the choices given here? Answer A, to measure the impurity or randomness of a data set, B, to calculate the variance of the target variable, and C, to normalize the distribution of residuals, D, to penalize complex models. So what will be the answer? Entropy means to measure the impurity or randomness of data set. So answer is A. Next, fifth question, which criteria is commonly used to measure impurity? Here answers given: A, mean squared error, and B, information gain, and C, Gini index, and D, variance. So here to measure impurity means we are having answer information gain, Gini index, and then Gini index. And entropy. Entropy is not available here. So here only one answer, that is C, this Gini index, to measure the impurity. Next is question, what's the primary disadvantage of using decision trees and machine learning? Answer A, they are prone to overfitting, especially with noisy data, and B, they cannot handle both categorical and numerical variables. C, they require extensive pre-processing of data. D, they are computationally expensive for large data sets. So what will be the answer? That is advantage of decision tree is A, that is they are prone to overfitting, especially with noisy data. Here I have given answers for these questions. Next, thank you. Let me discuss, continue our class in next class. Thank you.